tutorial explains how to make a one-point calibration curve based on the compound table we created. For this we select calibration curve window. To open up the method we stored, we activate the Windows Explorer, and for this we select the method part of this Explorer. We press right mouse button, refresh, and then we find the calib method we just created. We click and drag that into this window. Now we can define how many calibration levels we want and also what quantitative method we are using. Here, this window looks very similar to what we had in qualitative analysis, but in qualitative analysis we have a peak integration for TIC. In quantitative parameters we have an integration of MC. For that reason, GCMS solution has two independent different sets of integration parameters. Integration of mass chromatograms usually is different because the peaks have a better signal to noise, so slopes will be different in integration. That's the reason GCMS solution offers this flexibility. We select quantification here, and we can define the corresponding calibration, in this case external standard. We calculate area, and the number of calibration levels can be defined here. Curve fit type is usually linear. We can force the curve through 0 or not. Usually I prefer not forced because the instrument gives the points and 0 is not one point of the instrument. We don't use any weighting here at the moment. The units is just for a guidance. This doesn't make any quantification on that. We can select the decimal, and at the moment we ignore grouping. The identification is based usually on a window in percent or a band in absolute minutes. This means inside this time interval the software tries to identify the targets. In addition to the retention time, we can use reference ions. So the software checks the qualifier ions and the ratios to the target ions, and it should be within this allowance. Also, it's possible to use in addition or only the mass spectrum. And so we can uncheck reference and we can check mass spectrum. This method is preferred in very unclean chromatograms because if there is coelution, target ions easily fail the reference ion criterion because there might be one interference mass, and then as a result the compound is not identified. But when we use a mass spectrum pattern, it is very often better than 70%, and that will be identified as a compound. So in unclean spectra I would prefer mass spectrum pattern. So that's okay then so far. Peak integration can be done on slope, or if we take outer area, number of peaks. A number of peaks usually is just one in the quantification ion method, but I will explain later 2 is a good way to use. In comparison to qualitative analysis, where we integrate the whole chromatogram, here we only integrate the mass chromatogram, the mass we want to quantify. That's all to be said at the moment. So we see the 3 levels, and we have to adopt the corresponding concentration. This is done by edit. And then we are able to change the corresponding concentrations here, and if they're all the same, it's very easy to copy and paste them. So we now see the corresponding concentrations here. How to create a calibration curve manually in this window. We activate the Explorer, and then we put the Explorer on data file, and then we can click and drag any of the data file we want to calibrate with into this tree. Say for example scan past is level number 1. The software directly comes with a calibration curve. This is a one-point calibration. For example, for the first compound here, this is dichlorophosph. This is the M divided by Z target ion 109. 109 is the one integrated. We see here now, this is just one peak we quantify. So number of peaks to be integrated could be 1 in the quantitative window here, but sometimes there are 2 peaks inside that window, and then GCMS solution tries to identify always the biggest. So usually therefore I put number of integrated peaks 2. In this case it doesn't matter, it found the right peak, and also for all the others. To make a second calibration, it's the same way, a second level calibration here, so we would drag and another data file for level number 2 in here, and so on. This is a manual way and can be done automatically in batch table processing. So this is now the way to create a method, and just saving that method means this method is now saved with a calibration curve. And to process and quantify unknown runs, we go to quantify, and any of the data file, unknown data files can be dragged in, and we see there is no calibration curve in this data file. We click to method directory, refresh here also. We load the calibrated method into here, and we press OK, and now we see there is a calibration curve, but there is no integration of the unknown. To really calculate now the concentration of this unknown relative to the calibration curve, we again click quantitative peak integration. The quantitation parameters here are obviously the same like we used. We take the smoothing out, we don't want to have smoothing here, and now we peak integrate. The window pops up again, I press OK, and now I got a result. I use the same data file, so the calculated concentration based on the area is the same here, and on the result I see all the calculated result. Saving that data file is saving all the calculated results.